Example 1. Find the roots of the following quadratic equation, 6x square minus x minus 2 equals 0, by applying quadratic formula. Solution. Given equation is 6x square minus x minus 2 equals 0. On comparing this equation with ax square plus bx plus c equals 0, where a equals 6, b equals minus 1, and c equals minus 2. By using quadratic formula, x equals minus b, plus or minus, square root of, b square minus 4ac, is divided by, 2a, we obtain. This implies that x equals, minus of, minus 1, plus or minus square root of, minus 1, square minus 4 into, 6, into, minus 2, is divided by 2 into, 6. This implies that x equals, 1 plus or minus square root of, 1 plus 24 into 2 is divided by 12. This implies that x equals 1 plus or minus square root of 1 plus 48 is divided by 12. This implies that x equals 1 plus or minus root 49 by 12. This implies that x equals 1 plus or minus 7 by 12. This implies that x equals 1 plus 7 by 12, or x equals 1 minus 7 by 12. This implies that x equals 8 by 12, or x equals minus 6 by 12. This implies that x equals 2 by 3, or x equals minus 1 by 2. Therefore, 2 by 3, and minus 1 by 2, are the roots, obtained by applying quadratic formula. Example 2. Find two consecutive odd positive integers, sum of whose squares is 290, by applying quadratic formula. Solution. Let the smaller of two consecutive odd positive integer is x. Then, the next odd positive integer will be x plus 2. Given that the sum of squares of two consecutive odd positive integers equals 290. This implies that x square plus x plus 2 square equals 290. This implies that x square plus 4x plus 4 minus 290 equals 0, since a plus b whole square equals a square plus 2ab plus b square. Here, a equals 1, b equals 2. This implies that 2x square plus 4x plus 4 minus 290 equals 0. This implies that 2x square plus 4x plus 286 equals 0. This implies that 2 into x square plus 2x plus 143 equals 0. On simplification we get x square plus 2x plus 143 equals 0. Now we need to find the roots of above equation, that is, x square plus 2x plus 143 equals 0. On comparing this equation with ax square plus bx plus c equals 0, we have a equals 1, b equals 2, and c equals 143. By using quadratic formula, that is, x equals minus b, plus or minus, square root of, b square minus 4ac, is divided by, 2a. We obtain x equals, minus 2 plus, or minus square root of, 2, square minus 4 into, 1, into, minus 143, is divided by 2 into, 1. This implies that x equals, minus 2 plus, or minus square root of, 4 plus 572, is divided by 2. This implies that x equals, minus 2 plus or minus root, 576, by 2. This implies that x equals, minus 2 plus, or minus square root of, 24 into 24, by 2. This implies that x equals, minus 2 plus or minus 24, by 2. This implies that x equals, minus 2 plus 24, by 2, or x equals, minus 2 minus 24, by 2. This implies that x equals, 22, by 2, or x equals, minus 26, by 2. This implies that x equals 11, or x equals minus 13. For x equals 11, the two consecutive odd positive integers are 11 and 13. Find the roots of the following quadratic equation: 2x square minus 7x plus 3 equals 0, by applying quadratic formula. Solution. Given equation is 2x square minus 7x plus 3 equals 0. On comparing this equation with ax square plus bx plus c equals 0, where a equals 2, b equals minus 7, c equals 3. By using quadratic formula, that is, x equals minus b, plus or minus, square root of, b square minus 4ac, is divided by, 2a, we obtain x equals, minus of, minus 7, plus or minus square root of, minus 7, into 2 minus 4 into 2, into 3, is divided by 2 into 2. This implies that x equals, 7 plus or minus square root of, 49 minus 24, is divided by 4. This implies that x equals, 7 plus or minus root, 25, by 4. This implies that x equals, 7 plus or minus 5, by 4. This implies that x equals, 7 plus 5, by 4, or x equals, 7 minus 5, by 4. This implies that x equals, 12, by 4, or x equals, 2, by 4. This implies that x equals 3, or x equals 1 by 2. Therefore, the roots of the given equation are x equals 3, or x equals 1 by 2.